This is lesson 3.6, all about proportional and non-proportional relationships. So basically a proportional relationship is when you have a linear equation, meaning when you graph the solutions to a linear equation, it forms a straight line on a coordinate plane. It has an x and a y, an independent and a dependent variable. And it's proportional if 0, 0 is a solution. Basically, when you graph it, if it goes through the origin, if that straight line passes through the origin, then it is a proportional relationship. So you can say 0, 0 solution. It has to have that to be proportional. And it has to be in the form y equals kx, where k is the slope. Or you could say y equals mx, right? Instead of mx plus b, there isn't anything else hanging off the end of this equation. It's just a number in front of x. A non-proportional relationship is any other linear equation. It will not have 0, 0 as a solution, but it will still be a linear equation. So 0, 0, not a solution. All right, and it's easy to check these because all you have to do is plug a 0 in for x, solve, and you should get a 0 for y if it's proportional. If you do not get that, then it's not proportional. Easy enough to check. All right, so here's an example. Compact disc. Suppose you purchase a number of packages of blank CDs. If each package contains 3 CDs, you can make a chart to show the relationship between the number of packages of CDs and the number of CDs purchased. Use X for the number of packages and Y for the number of CDs, right? So one package has 3 CDs in it. Make a table of ordered pairs, right? So one package, 3 CDs, 2 packages has 6 CDs, 3 has 9 CDs, 4 packages has 12, 5 has 15, right? So we're gonna look at the relationship. Now, number of packages is our X value, and the number of CDs is our Y value. The number of CDs we buy depends on how many packages we buy, right? So independent variable, dependent variable. So the relationship here from 1 to 2 is, I just added 1, right? 2 to 3, I'm just going up by 1 continually. 4 to 5, I just go up by 1. And then down here for our Y variables, this is continuous, this is constant, we're going up at the same rate. So we want to see the same thing here. 3 to 6, I went up by 3. 6 to 9, I went up by 3. 9 to 12, again, up by 3. 12 to 15, up by 3. So I can see this is definitely a linear equation, right? If I wanted to figure out if it's a proportional relationship, I need to figure out if 0, 0 is a solution. To figure out if 0, 0 is a solution, I need to write an equation for this, right? So I'm going to use y equals kx. I got to figure out the slope of this equation. So for the slope, I'm going to use y minus, I'll do it over here on the side, y minus y over x minus x, right? And I can just use any 2 pairs here. Y is on the bottom, x is on top, so I'm going to use 12 minus 15 over 4 minus 5. That's negative 3 over negative 1, which is positive 3. So my slope is 3. So for y equals kx, I'm going to use y equals 3x, right? And then I have to see if 0, 0 works. So y equals 3 times 0. 3 times 0 is 0, so I would get 0 equals 0. That checks out. I do want to check and make sure this is the correct equation, and that I'm not missing something on the end. So I'm going to plug in a couple of these, right? So when y is 3, x is 1, 3 equals x is 3, or sorry, k is 3, x is 1. That is true. Good. I'm using this equation, y equals 3x. Another one would be when y is 6, x is 2. So 6 equals this 3 times x, which is 2. 6 equals 6. That is correct, right? So I know this is the correct equation. And I know that it is proportional because when I plug in a 0 for x, I get 0 for y. 0, 0 is a solution. When x is 0, y is 0. So this is proportional. A linear equation that has 0, 0 as a solution is proportional. All right, some exercises we can do together now. Natural gas. Natural gas use is often measured in therms. The total amount a gas company will charge for a natural gas use is based on how much natural gas a household uses. The table shows the relationship between natural gas use and the total cost. So gas used is our X variable, and the total cost, which depends on how much gas you use, is our Y variable. Okay, so graph the data. What can you deduce from the pattern about the relationship between the number of therms used and the total cost? Well, we can probably figure out real quick if it's linear or not, right? The top is increasing by 1 at a steady rate. The bottom here, 130 to 260, it went up by $1.30. 260 to 390, it went up by $1.30. 390 to 520 went up by $1.30. So this is linear. It's going up at a constant rate, right? So we're going to graph these. So therms used, when I use 1 therm, it cost me $1.30. So over 1, up right about here. 2 costs $2.60, over 2, up right about here. That's $2.60. 3 is $3.90, over 3, just under 4. And 4 is $5.20, so over 4, up $5.20. Right, so it's going to look something like that. It will be a linear equation because it's increasing at a constant rate, although my line doesn't look perfectly straight. It is. And it says, what can you deduce from the pattern about this relationship between the number of therms and the total cost? So we can say total cost increases by $1.30 per therm. So the more therms you use, each therm goes up by $1.30. B, write an equation to describe this relationship, right? So we want to write an equation. So we're going to use y equals kx. K is my slope. So my slope is the change in y over the change in x. The change in y is $1.30. The change in x is 1. So my slope is $1.30 over 1. So my equation, y equals $1.30 times x. And I have to make sure that there's nothing else that I'm missing in this equation. So if I plug in a 2, $1.30 times 2 would be $2.60, which is my y value. So that works. If I plugged in a 3, $1.30 times 3 is $3.90. That's here. So this is my equation. And use this equation to predict how much it will cost if a household uses 40 therms. So y equals 1.3 times 40. 40 is the number of therms. And if I use my calculator, 52. $52 is the total cost for $1.30 per therm times 40 therms. Hopefully that makes sense. If I plugged in a 0 to this, I would get 0, 0. If I plugged in a 0 to this equation, $1.30 times 0 is 0. So my solution here would be 0, 0. On my graph here, if I kept graphing it straight, it would go straight through this 0, 0 origin right here if my line had been straight the way I drew it. And that would be a solution. So this is proportional. You can write that here. We're going to do a few examples so you'll get a better idea of what I mean by proportional. Okay, and I am going to keep this all in one video. I have a second sheet here. Write an equation and function notation for the relation shown in the table, then complete the table. All right, so here, looks like we're going up by 1 across the top, right? -1 plus 1 is 0, 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. What am I doing on the bottom? -2 to +2, I added 4. +2 to +6, I added 4. So if I add 4 again, 6 plus 4 is 10. 10 plus 4 is 14. And 14 plus 4 is 18. So here's my table. My equation would be y equals my slope, change in y over change in x, that's 4 over 1, 4x. However, when I plug a 0 in for x, y is not 0. So this is not proportional, right? What did I do to the 0 here to get 2? I added 2. So in my equation, I'm going to add 2 on the end. So here's my equation. If you find x and it's 0, see what the y value is. If it's 0, then you know this is proportional and there's nothing hanging off the end here. This just goes away and our equation's y equals 4x. If it's another number, that number was either added or subtracted from 0, so you have to add or subtract it from the end of your equation. Okay, from here to here to here to here, I'm adding 1 along the top. What am I doing on the bottom? To get from 10 to 7, I subtracted 3. Here I subtracted 3. So 4 minus 3 is 1. 1 minus 3 is negative 2. And negative 2 minus 3 is negative 5. Okay, I'm going to find where x equals 0. I'm going to highlight it here. Same thing over here, I should have highlighted it. Okay, if y is 0, then this is proportional. It is not proportional, y is 4. So I'm gonna have my equation, y equals the slope, change in y over the change in x. Change in x here is 1, constantly. So change in y over change in x equals negative 3 over 1. So I know my slope is negative 3. So I'm gonna write negative 3x. And if this was proportional, this would be my equation, I'd be done. However, it's not proportional because when x is 0, y is not 0. So what is y gonna be? What did I do to 0 here to get 4? I added 4, so I have to add 4 to my equation. I hope that's making sense. Okay, and then if we wanted to test out a couple of these, we could. If I plug a negative 2 in for x, negative 3 times negative 2 is positive 6, and positive 6 plus 4 is 10, which is what my y value is. So this equation works. All right. 4 and 5, we have to use the graphs here. Write an equation in function notation for each relation. Oh, I didn't do this in function notation up here, sorry. This said to write an equation in function notation. Remember, we replace y with f of x. So here it would be f of x equals 4x plus 2. This would be my function notation equation here. And over here, this would be f of x equals negative 3x plus 4. This would be my function notation equation for number 3. Sorry, I didn't complete that. Same thing, f of x is y. It's just written in function notation here. Okay, write an equation in function notation for each relation. So here, I got to figure out the slope, and I got to figure out the y-intercept, right? So I got y equals kx. I want to figure out the slope. The slope is rise over run, right? Change in y over change in x. So to get from one point to another, I'm going down 1 over 1. So my slope is down 1 over 1. Or in other words, y equals negative x, right? But I'm not done there. That's if this, this line was proportional. If it goes through the origin, it's proportional. But our line doesn't go through the origin. So what did I do to the line? Which direction did I move it, up or down, if it started here at 0, 0? I moved it up 2, right? I went up the y-axis 2. So I have to add 2 onto the end of my equation. Right? So this is my equation, and then if I want it in function notation, I say f of x equals negative x plus 2. This is my function notation equation. This is this line. Hopefully that's making sense to you guys. Let's do another one. Is this proportional? Does it go through 0, 0 right here? No, it does not. It looks like it got raised up 2. So here our y-intercept, instead of being at 0, we added 2 onto that. So here, y equals kx. My slope to get from one point on the line to the next, when I read from left to right, I always read a graph from left to right, I had to go up 2 over 1 to get from one point to the next. So my slope is up 2 over 1, x. And then it's not plus 0 on the end here because I'm not crossing at 0. I'm crossing at 2. So y equals 2x plus 2. I have to add that 2 onto the end to know that I moved my line up 2 from the origin. And then to write it in function notation, I just changed that y to f of x. Don't overthink it. It's literally just changing y to f of x. It's literally looking at this line. Think of this line as normally going through these points this way. If this red line was my line, it goes through the origin. So the equation of that line would just be y equals 2x. But it's not this line. We moved it up to. It crosses my y-axis up to. So I had to add 2 onto the end of y equals 2x. That's why there's a plus 2 on the end. Okay, hopefully that's making sense. Last 3. Tell whether each function is proportional or non-proportional. We don't even have to explain. So if it goes through 0, 0, it is proportional. Does this go through 0, 0? Yes, it does. So this is proportional. If we wanted to, it doesn't tell us to, but if we wanted to write an equation for this line, we're going to use y equals kx. It's proportional, so we're not going to add or subtract anything onto the end. Okay, and then what's my slope? Well, it looks like here's a point on my line. Here's another point on my line. So to get from this point to this point, I had to go down 1, 2, 3, 4 over 2. Negative 4 over 2. And negative 4 over 2 simplifies to just negative 2, right? So my slope is negative 2. So my equation of that line is y equals negative 2x. Makes sense? If I went backwards 1, if my x value is negative 1, what should my y value be? Negative 1 comma 2, right? So if I plug a negative 1 in here, negative 2 times negative 1 is positive 2. That's what I wanted. That lies on my line. So I know this is the correct equation. Second one, number 7. Does my line pass through the origin? No, it does not. So this is non-proportional. Right? If I wanted to write an equation of this line, y equals kx, and I know I'm going to have to add something onto the end, add or subtract. So first I want to find my slope. I'm reading this from left to right. Looks like this is a point on my line. And it looks like I'm just going up 1 over 1 to stay on my line. Up 1 over 1, up 1 over 1. So my slope is just 1. Y equals 1x. And then instead of my line going through the origin, it actually crosses over the y-axis 2 down here at negative 2. So I'm going to subtract 2. So my equation for that line would be y equals x minus 2. Whenever you have a proportional equation, it just has y equals a number times x. When it's non-proportional, it's y equals a number times x plus or minus something else hanging off the end here. So this is not proportional. And then lastly, this is also not proportional. Non-proportional. And if we wanted to write an equation of this line, we start with y equals kx. The slope here is also up 1 over 1. 1 over 1, up 1 over 1. So y equals 1x. And then I didn't cross here at 0. I crossed at 1, 2, 3, 4, 5, 6, positive 6. So I add a 6 onto the end. So the equation of this line is y equals x plus 6. But you didn't have to write an equation. You just had to tell if it was proportional or not. If it goes through the origin, it's proportional. If it doesn't, it's not proportional. Let me know if you have questions.